So you might be wondering, is there a better way to do balancing equations that doesn't involve drawing every molecule out? And the answer is yes. You can do it with numbers and just enumerating things on each side of the chemical equation. So this is a method I think that works pretty well. I like to draw a line first between where the equation has its arrow. Okay, so I draw a line right there. What I'd like you to do is, while you're taking notes, do this. Just go ahead and do exactly what we're doing here on your paper and follow along. This is the method for balancing equations. It works very, very well, and it just requires that you use paper and pencil. So the first thing we do is we enumerate, we list out all of the different elements involved in this reaction. So we'll go ahead and list H, that's hydrogen, and we'll list O, that's oxygen. And we'll count how many different things there are on each side. Let's also just do that on the reactant side as well. So these are the product side as well. So this is the reactant side, okay, on that side, and then this is going to be the product side. On this side, on the product side, I have H2O, so I've got H and I have O. Now, if you remember from the last video, we said that there's always going to be the same stuff on every side. Same exact atoms. You can't have new atoms on one side that didn't come from the other side. So it's actually a really good way to just double check that you've read the equation correctly and that you're understanding what's going on. So we've listed them out. There's the same on each side. Great. This is a good equation. Now I just need to balance them. So I'm going to list out how many hydrogens there are and how many oxygens there are. How many hydrogens are there? There are 2, because there's an H here and a 2, a lower subscript 2, which symbolizes there's 2 in a molecule. Okay, how many oxygens are there? There are 2 as well on the reactant side. Now I'm going to compare it to the product side. How many hydrogens are there on the product side? There are 2. This 2 is always in reference to the element that is on the left. So don't get confused. Don't think that the 2 goes with the O. It doesn't go with the oxygen. So there's 2 of those. How many oxygens are there though? Only 1. Not balanced, right? This is the unbalanced part. The 2 and the 1, they're unbalanced. How do I balance them? Well, it's pretty simple. I'm going to address the molecule that has the problem first. So which molecule has the problem? This molecule has the problem. I'm going to fix its problem by putting a coefficient, which is a big number that goes in front of the entire molecule. I'm going to put a coefficient in that's going to fix the problem. And what's the problem? I need to have 2 of these, not 1 of them. And the coefficient basically acts like a multiplier. So if I put the coefficient of a 2 right here, the 2 distributes to everything that's in there, because we're saying there's two molecules of water, so there's 2 of all the stuff in there. So if you've ever played one of those puzzle games where you kind of like have to move all the different puzzle pieces, or maybe like a Rubik's Cube, when you fix one problem, you end up making more problems later that you have to solve. And eventually, if you work it all out, the picture resolves and you've completed the puzzle. And that's kind of what we're doing here. So we're going to fix one problem and then make another one in the process. But it's all part of the game. So what you have to do in order to make it work. So I've put a 2 in front, and that's going to make me have 2 oxygens. But it's also going to make me have 2 times 2 is 4 hydrogens. So you always have to make sure you distribute that correctly and know that if there are any subscripts, it's going to multiply. 2 times 2, and technically there's a 1 right here. We just don't bother writing the 1, but 2 times 1 is 2, of course. So now I've got 2 and 2. These are good to go. I could even put a check next to it if I'd like, but the hydrogens aren't good to go anymore. So how do I fix that? Well, actually, I can pretty simply fix the hydrogens by going to the left side. I need to get 4 hydrogens. How do I do that? Put a 2 in front. And now the 2 distributes to H2, and 2 times 2 is 4. So I've now balanced the equation. If you remember from last time, that was the equation we ended up with. The only thing to note is that I didn't put a 1 right here because it's implied. If there's at least, 1 oxygen in there, we're going to just write it like that. So there's no reason to put a 1 there, but you can put it there if you like, if it makes sense to you how many things there are. And we would call this a ratio. in the end. We're going to sort of understand that the ratio of hydrogens to the number of oxygens is 2 to 1. The number of water molecules there are to hydrogen molecules that there are in the reactants is 2 to 2 or 1 to 1, however you want to think about that. And the ratio of oxygen atoms to the number of water molecules made is 1 to 2. So always thinking about those numbers in front really helping us understand what the recipe is in order to make water. Okay, so how about a harder situation? Well, I can use the same method to actually work out a more difficult problem. So here's a new problem. NH3 plus O2 yields N2 plus H2O. Okay, I'll just say that verbally. Ammonia plus oxygen yields nitrogen gas and water. Those are those chemicals. So regardless of if you've ever heard of this chemical reaction before or not, we can still work to balance it. So that's what we're going to do here. I'm going to do the first step and draw the line and just see, maybe somehow magically it is going to be balanced. Who knows? So I'll go ahead and draw a line between the two. Remember, follow along with me as you're taking notes. So draw a line right here after we rewrite this equation. So now that we've got the equation written and we've got our line, what we're going to do is enumerate all the different molecules that are, the atoms that are in here, excuse me. So let's start off left to right. We'll just go until we get everything written down. There's an N, it's nitrogen. There's an H, that's hydrogen. And there's an O, that's oxygen. Let's do it on the right side as well. So that was the reactants. Let's do the products. Here's the nitrogen, here's the hydrogen, and here's the oxygen. And look at that. They're all the same on each side. They should be that way, but we want to double check that we've done everything correct and that we're understanding how that works. So and another thing to just note is when you're doing these, there should be the order that you're putting them in should be the same kind of across each side. That way you're able to compare left and right pretty quickly. So it should be the same stuff on each side, but sometimes the order isn't going to perfectly do that. It just happened to this time. Okay, so let's go ahead and enumerate how many things there are. First, there's one nitrogen. I don't see any subscripts here. It's just a nitrogen atom. And that atom is bound to 3 hydrogen atoms, H3. So that's a molecule here, ammonia, which has a nitrogen with 3 hydrogens around it. And that gets added to, in this reaction, just oxygen gas, O2. And there's 2 of those atoms there. All right, let's see what we're dealing with on the right side. Nitrogen gas, which is N2, is 2 atoms. So I've already got an imbalance there. It's okay. We'll fix it and we'll work it out. H2. Okay, there's 2 of those. Wow, 3 of those and 2 of those. Okay, this is all messed up. And only 1 oxygen. Okay, so across the board, I have, problems. This might seem kind of intimidating, like where do I start? The answer is just start at the top, and you'll work your way down, and it will work out. So the first thing to do is to try to let's go one problem at a time. Let's try to fix the nitrogens. I need to add more nitrogens to this equation in order to make the 2's balance. Let's try to do that. I'm going to go ahead and add a 2 in front. Now I have 2, but I also want to make sure to update anything else that I've changed. So I've also added, these are 2 molecules of ammonia, and each molecule of ammonia has 3 hydrogens in it. So if I now have 2 molecules of ammonia, I now have 6. 2 times 3 is 6. Okay, I haven't changed anything else. So let's see what the damage is and see if we can do any fixing. So the nitrogens are done. The hydrogens are super imbalanced, but what do I need in order to balance this? There's 2 on this side, there's 6 on this side. Well, I know if I can multiply that 2 times 3, I'll be able to get to 6. So you can think of your multiplication tables here to help you out a little bit. Let's see where the hydrogens are. I have H2O over here. Okay, cool. So if I put a 3 in front of that, 3 times 2 will be 6, and I'll actually have balanced hydrogens. It's not too bad. The hydrogens are balanced. but I also did some damage to my oxygens, right? Now I have 3 oxygens. Okay, so let's update the oxygens. There's 3 and 2. So now I'm in kind of a bit of a pickle, right? Because I know that I can't make 3 oxygens on the left side. This is sort of tricky, right? How do I fix the 2 and the 3, because those things don't go into each other? I can't make 2 and 3 work. You could think, well, maybe I can go 1.5. Maybe some of you were thinking that. I can go decimal, and 1.5 times 2 is 3. Actually, this method can work for you temporarily, but think about the logic behind this. Can I have a half of a molecule? I can't, right? I can't have half of something that only exists as a whole. So it's sort of a mathematical band-aid, if you like, but it doesn't work in practice. So what we're going to do is we'll use the 1.5 and go with that for now. And now I do have a balanced equation, but I don't have a real equation. It doesn't work like this. All I've done is made the math balance, but I haven't actually made the equation make sense. So because I can't have this decimal, what do? Well, here's this really awesome part where your math background is going to help you. I am going to use the distributive property of, I think that's what it's called, of multiplication, where I take something I'm going to do like in algebra, where I take stuff on the left and I make the left equal the right by multiplying. So here's where your math backgrounds can come to help you, especially what you did in algebra, where you try to make the left side equal to the right side, and you multiply whatever you do on the left, you do on the right. So here's where your math background can actually help you out, where the stuff that you maybe remember from algebra, if you do something to the left side of an equation, you have to do, or the left side, you have to do that to the right side of the equation as well. So here's what we're going to do to the left side of the equation. How do I make that 1.5 not a decimal anymore? Well, I can multiply 1.5 times 2 and I'll get the number 3, right? 1.5 times 2 equals 3. So I'm going to multiply the entire equation by the number 2. Okay, so everything in that equation is going to get multiplied by the number 2. Or if you like, we can multiply this side by the number 2, and we multiply this side by the number 2. However you want to think about it, but we're just doing the same thing to both sides. We're doubling up everything so that we can have a full whole number in front of oxygen now. So let's go ahead and rewrite it so that we can understand what we're doing and what our numbers are going to be. Okay, so basically what I'm going to do now is multiply across the 2 to each of the coefficients that are in front of those letters. So 2 times 2 is 4. 2 times 1.5 is 3. 2 times, there's a 1 here, right? But I didn't write it, so 2 times 1 is 2. Oops. I lost my 2 there. And then 2 times 3 is going to be 6. Now, that was a little more difficult, but if I remember, I had already balanced everything at the bottom, right? And I know that if I multiplied these numbers by 5 or a billion or 15 or whatever it is, if I multiply them all by the same number, they're still going to be equal because they all got multiplied by the same number. And in this case, I just multiplied all those numbers by 2, and now basically every number that's down here got multiplied by the number 2 when I did this right here. So those do balance. Each side does balance, and you can go back and confirm that if you go ahead and count everything up. The N's are going to balance. There's 4 on each side. The H's are going to balance. There's 12 on each side. And then the O's are going to balance because there's 6 on each side. So this is a more difficult equation to balance. It took a few steps, but it just took a little bit of kind of tweaking and figuring out which numbers go in front. Okay, so that's more advanced equation balancing using math. I hope that was helpful.